All right, let's go over this class starter. Don't forget, tomorrow you have a quiz, and it's going to be on multiplying and dividing polynomials like we did last Thursday. You had that worksheet in class on Friday. And it's also going to be on what we did yesterday, which was putting polynomials in standard form, classifying them by their degree, the number of terms that they have, and then discussing their end behavior. And that's what you're asked to do here on number 1 and 2. They're already written for you in standard form, so we don't have to worry about that. So for number 1, how would you classify that polynomial? First off, is it a polynomial?
Yes.
Yeah, how do we know? Good. Good. So the exponent is a whole number. So that means there's no fractions, there's no decimals, and it's not negative. And then what else do we have to have? What has to be the case with these coefficients and constants? What do they have to be?
Real numbers.
Real numbers, right. So we can't have an imaginary number as part of our polynomial. They have to be real numbers, but 3 and 7 both are. So it meets the requirements for it to be a polynomial, so we're good there. So then if we're going to classify it, we're going to classify it by its degree, which is its biggest exponent. And that biggest exponent is 2, so what does that mean?
Quadratic.
It's quadratic. And then how many terms does it have?
2.
So that means it's also a binomial. Good. So it's a quadratic binomial. What's the leading coefficient? 3. And because the degree is even,
How you know degree?
biggest exponent. So the biggest exponent is 2. So the degree is even and the leading coefficient is positive, then we can describe the end behavior. And remember, when we're describing the end behavior, what we're doing is we're going to determine what's happening in the function as x approaches positive and negative infinity. Sorry, my board's messed up right there. Okay, so I'm looking as x goes towards negative infinity and as x goes towards positive infinity, what are the y coordinates doing? Okay, how do you know? Good, so whenever the degree is even, they both go in the same direction, either both up or both down. And then to take the determination, we look at the leading coefficient. If the leading coefficient is positive, that means they're both going up. So as x goes towards negative infinity, what's f of x approaching? And as x approaches positive infinity, f of x approaches. Good. Okay. So what that means for the end behavior is that in both directions, at the extremes, it's pointed upward. You don't have to. No, that's just kind of the visual for me. Everybody good on number 1? All right, number 2, we're going to do the same thing. It's already written in standard form for you. So what is the biggest exponent of the degree?
3. 20. I don't know what's a 5. It's 5.
So that means
20.
20. Okay. And then how many terms does it have?
It has 5.
So we're going to call it a quintic polynomial of 5 terms. Okay. And of course, we know it's a polynomial because we look at all the exponents and their whole numbers, and then we looked at all the numbers, coefficients, and constants, and there's no imaginary. What is the leading coefficient? -1. So we know the leading coefficient is negative, and then is the degree even or odd? Okay. So when we start describing the end behavior as x approaches negative infinity and positive infinity, then what does an odd degree tell you? Okay, and with the leading coefficient being negative, how does that work? What does that look like? So on the left-hand side, it's going up. On the right-hand side, it's going down. So that means that as x goes towards negative infinity, what is f of x doing, or the y coordinate doing? Good. And as x goes towards positive infinity, the y coordinates go towards negative infinity. Okay? And again, it's all based on the degree and the leading coefficient. And so you either just have to memorize that, or you have to memorize what the graph would look like, so you know what the extremes are going to look like, so you can describe that in behavior. Any questions on 1 or 2? Then I told you to skip 3 and 4. And so we're going to look at 5 and 6, and what it asks you to do is to factor these expressions. So kind of going back to what we did in the last unit, where we were factoring expressions, we had the first thing that we look for anytime we factor is what? GCF. So for number 5, is there a GCF? 3x cubed. And what are you left with after you take out that GCF? 64.
Perfect.
Very good. And that is the difference of 2 perfect cubes. So that means that what's left over is also going to be factorable. So we start by taking the cubic root of each term, which is going to leave me with what?
3x.
And then we're going to find the trinomial. How do we do that? Good. So we'll square the first term, which is, and we'll do the opposite sign. So instead of the minus, it'll be a plus. Then product says 3x times 4, which is, and plus, and we square the last term, and 4 squared would be 16. Okay. And what do we remember about that trinomial?
It can't be factored.
Can't be factored. So in terms of factoring this, we're done. That's as far as we can factor. Everybody good there? And what we're going to be building to is, starting tomorrow, is we're going to look at how we find the zeros of the polynomials. And remember, the zeros of the polynomial are the values of x that make the whole thing equal to 0. So at this point tomorrow, what we're going to do is we're going to imagine now that this is equal to 0, and we're going to figure out what x is. So obviously x would be 0, another 0 would be 4/3, and then we would have to use the quadratic formula to figure out what the zeros are of that trinomial. So that's tomorrow. Today we're just worried about factoring. So for number 7, what do we have to do first? And what would the GCF be? And what are you left with? But we're left with a trinomial, and one thing that we always look for when we have a trinomial is the middle term's exponent half the first term's exponent? And is that the case here? Yeah, so actually we might be able to factor. What we would need is 2 numbers that multiply to 4 and add to -5. And what? Good, -1, -4. The coefficient of this x to the 4th is 1, so we put 1 over -1 and 1 over -4. Those don't reduce, so that trinomial will factor into what?
1x minus 1. 1x minus 1.
All right, but instead of x, it's going to be x squared. So x squared minus 1 and x squared minus 4. We need them to be x squared so that if we were to FOIL, we would get x to the 4th power. Well, what do you notice about those?
They're perfect squares.
Yeah, that's the difference of perfect squares. So each of those can be factored further. So x minus 1, x plus 1, and x minus 2, x plus 2. And again, looking ahead to tomorrow, if we're going to look to see what causes this whole thing to equal 0, well, there's going to be a lot of things that make this equal 0. What all would make it equal to 0? And 0. Right. So 0 plus or minus 1 and plus or minus 2. All right. Next, number 6. Is there a GCF? No. Well, there's not a GCF for all 4 terms, but because there's 4 terms, then what does that indicate? Grouping. So we'll group the first 2 together, and we'll group the second 2 together, and we'll put a plus sign in between those 2 groupings. And now, what can we take out of the first grouping? And that would leave us with x plus 3. What can we take out of the second grouping?
-4.
That would leave us with x plus 3. And it looks like grouping is going to work because what was left over is the same, so we write it, cross it out, and what are you left with?
X squared minus
Which x squared minus 4 is
6 minus 2.
the difference of two perfect squares. So we have x plus 3, x minus 2, and x plus 2. Again, that would be easy for us to find the zeros of that, to figure out the values of x that would make the whole polynomial equal to 0. Say -3, 2, and negative. All right, and then finally, number 8, you have a GCF, and you're left with x squared minus 100. And so that would factor into x minus 10 and x plus 2. Good. All right, any questions on your class starter? Good. All right, then let's go to your homework. Let me pull up the answers. Answers are on the website. I'll pull them up here so you can check it real quick. 6.1. So here's the answers to the first 6. Actually, first 8.
If they're already in standard form, do we have to rewrite it?
Like which one? If the exponent's a fraction, then it's not a polynomial. But if a fraction's in the front, that's a real number. Everybody check through 8.
I emailed the positive I think with 7.
For the leading coefficient is like for number 9, for example, they're both going in the same direction, which means it's even. Each time the behavior goes in the same direction, it's even. And if they're both pointed up, it's positive. Yeah. For 7 and 8, well, for 7 and 10, they're going in opposite directions. So that means the degree is odd. And then it just depends, like for number 7, because the left side's going down and the right side's going up, that's a positive leading coefficient. Yeah. And then the other side, number 10, same thing. It's going from down to up, so that would be a positive leading coefficient.
Everyone's the other way around.
Yeah, so if we had, like 5 through 1 like this, then that would be an odd degree, but a negative leading coefficient.
So how do you know things that are odd?
Depending on if the end behavior is going in the same direction or opposite directions. So for 7 and 10, they're going in opposite directions, so the degree is odd. And for 9 and 8, they're going in the same direction, so the degree would be even. Everybody good through 10? Get rid of all this. And here's the end behavior for 11 through 14. those, you had to describe as x goes towards negative infinity and as x goes towards positive infinity, what are the y coordinates doing? And again, that's all based on the degree and whether that leading coefficient is positive or negative. And 15, 16, 17 just asked you to simplify those polynomials and write them in standard form and then classify them based on their degree and the number of terms. Do we need to go over any of those homework problems?
Does it get a lot harder than this section?
This is going to be everything that's going to be on your quiz tomorrow. And then after that, what we're going to do is we're going to start finding the zeros of polynomials. So we're going to take polynomials like we did on the class starter. We'll factor them and then set them equal to 0 and see what makes them equal to 0. I guess the difficult part is going to be is what happens when they don't factor. How are we going to find the zeros then? But that's what we're going to work on Wednesday, Thursday, and Friday. Am I good? All right. Don't forget about your quiz tomorrow.